In construction, straps and yokes are distinct structural elements with specific purposes. A strap is generally a short piece of material, commonly metal or leather, employed to secure or reinforce a structural member. In practice, it often presents as a flat, elongated piece of metal fastened, either bolted or welded, to a beam or column to enhance its support capability. Conversely, a yoke is a U-shaped or V-shaped device designed to fit around a member or object. Within construction contexts, a yoke typically serves as a structural member connecting two other members at their respective ends. Yokes play a crucial role in transferring loads, providing stability, and restricting movement within a structure. The primary distinction lies in their application. Straps are predominantly used for reinforcement and support, whereas yokes are used for connecting and transferring loads. Structurally, straps are characteristically flat and elongated, while yokes exhibit a U-shaped or V-shaped configuration. Attachment methods also differ. Straps are frequently used in conjunction with bolts or welds, while yokes may be connected through bolting, welding, or pinning mechanisms. Regarding the 2018 International Building Code IBC Section 314.16 B4, it pertains to connections of wood members to steel or concrete members. The code stipulates that these connections must be designed to withstand axial stresses, shear stresses, and moments transferred at the connection point, utilizing straps, bolts, or other approved devices. While this section doesn't explicitly define strap and yoke, it suggests that straps are one type of device suitable for connecting wood members to steel or concrete. Historical perspectives, such as those found in the 1950 Engineer's Handbook, offer further insights. The handbook describes straps as flat bars affixed to the ends of beams or columns to augment strength and rigidity. Yokes, in contrast, are depicted as U-shaped members employed to connect the ends of beams or columns. Delving deeper into straps, these elements are critical for enhancing the load-bearing capacity of structural members. When a beam or column is subjected to stress, straps can distribute the load more evenly, reducing the risk of failure. They are particularly useful in situations where the existing structure needs to be reinforced without significant alterations. The material choice for straps is vital, steel being a common selection due to its high tensile strength and durability. However, other materials like fiber-reinforced polymers are gaining traction for their lightweight and corrosion-resistant properties. The design of a strap involves careful calculation of the forces it will encounter. Engineers must consider factors such as the magnitude and direction of the load, the material properties of the strap and the structural member, and the geometry of the connection. Proper installation is equally important. A poorly installed strap can compromise the integrity of the entire structure. Welding or bolting must be performed by qualified professionals to ensure a secure and reliable connection. Moving on to yokes, these structural elements are essential for connecting and supporting multiple members. They are commonly used in bridge construction, scaffolding, and other applications where complex load transfer is required. The U-shape or V-shape of a yoke allows it to cradle the members it connects, providing a stable and secure joint. Yokes can be fabricated from various materials, including steel, concrete, and timber. Steel yokes are favored for their strength and ability to withstand high stresses. Concrete yokes are often used in bridge construction due to their compressive strength and resistance to environmental factors. Timber yokes, while less common, can be suitable for temporary structures or decorative applications. The design of a yoke involves intricate analysis of the forces acting on it. Engineers must consider the loads imposed by the connected members, the geometry of the yoke, and the material properties. Finite element analysis is often used to optimize the design and ensure that the yoke can withstand the anticipated stresses. The connection between a yoke and the structural members is crucial. Bolting, welding, or pinning are common methods, each with its advantages and disadvantages. Bolted connections allow for easy assembly and disassembly, while welded connections provide a more permanent and rigid joint. Pinned connections allow for some degree of rotation, which can be beneficial in certain applications. The 2018 International Building Code IBC provides guidelines for the design and construction of structural elements, including straps and yokes. Section 314.16. The 4 specifically addresses the connections of wood members to steel or concrete members. It emphasizes the importance of designing these connections to resist axial stresses, shear stresses, and moments. The code also references various standards and specifications that provide detailed requirements for materials, fabrication, and installation. Engineers must adhere to these codes and standards to ensure the safety and integrity of the structure. Looking back at the 1950 Engineer's Handbook, it offers a valuable historical perspective on structural engineering practices. While some of the materials and methods described in the handbook may be outdated, the fundamental principles remain relevant. The handbook's descriptions of straps and yokes provide insights into their traditional applications and design considerations. For instance, the handbook highlights the use of straps to reinforce beams and columns, increasing their load-carrying capacity. It also describes the use of yokes to connect and support multiple members, distributing loads effectively. Comparing modern practices with those described in the 1950 Engineer's Handbook reveals the evolution of structural engineering. Advances in materials analysis techniques and construction methods have led to more efficient and sophisticated designs. However, the basic principles of structural mechanics and the importance of careful design and installation remain unchanged. In summary, straps and yokes are essential structural elements with distinct roles in construction. Straps are primarily used for reinforcement and support, while yokes are used for connecting and transferring loads. The design and installation of these elements require careful consideration of the forces involved, the material properties, and the applicable codes and standards. Understanding the differences between straps and yokes is crucial for engineers, architects, and construction professionals to ensure the safety and stability of structures. In contemporary construction, the use of straps has expanded beyond traditional steel applications. Composite materials such as carbon fiber reinforced polymer CFRP are increasingly employed for their high strength-to-weight ratio and resistance to corrosion. These composite straps can be bonded to existing concrete or steel structures to enhance their load-bearing capacity without adding significant weight. The application of composite straps often involves surface preparation, adhesive application, and careful curing to ensure a strong bond. The design of composite strap reinforcement requires specialized knowledge of composite materials and their behavior under stress. Similarly, yoke designs have evolved to meet the demands of modern construction. Prefabricated steel yokes are commonly used in bridge construction, allowing for faster and more efficient assembly. These yokes are often designed with adjustable features to accommodate variations in geometry and alignment. Concrete yokes can be cast in place or precast, depending on the specific application. Precast concrete yokes offer the advantage of controlled quality and faster construction times. The use of advanced concrete mixes, such as high-performance concrete and self-consolidating concrete, can further enhance the durability and strength of concrete yokes. In complex structural systems, the interaction between straps and yokes can be critical. For example, in a steel frame building, straps may be used to reinforce columns, while yokes connect beams to the columns. The combined effect of these elements contributes to the overall stability and load-carrying capacity of the structure. Engineers must carefully analyze the interaction between straps and yokes to ensure that the structure can withstand the anticipated loads and stresses. Building information modeling (BIM) software is increasingly used to model and analyze complex structural systems. BIM allows engineers to visualize the structure in 3 dimensions, identify potential conflicts, and optimize the design for efficiency and safety. The use of BIM can also improve communication and collaboration among the various stakeholders in a construction project. The long-term performance of straps and yokes is an important consideration in structural design. Factors such as corrosion, fatigue, and environmental exposure can affect the durability and strength of these elements. Regular inspection and maintenance are essential to identify and address any potential problems. Non-destructive testing methods such as ultrasonic testing and radiographic testing can be used to assess the condition of straps and yokes without damaging the structure. Protective coatings and corrosion inhibitors can be applied to steel straps and yokes to extend their service life. In conclusion, the selection and application of straps and yokes are integral to ensuring structural integrity in diverse construction scenarios. Whether employing traditional materials like steel or embracing innovative composites, a thorough understanding of their respective roles, design considerations, and installation techniques is paramount for engineers and construction professionals. The evolution of these elements, guided by advancements in materials science analysis methods and construction practices, underscores the ongoing pursuit of safer, more efficient, and sustainable structures. The integration of building information modeling (BIM) further enhances the ability to model and analyze complex structural systems, optimizing designs for both performance and longevity. Continual vigilance in inspection and maintenance, coupled with the application of protective measures, ensures the enduring reliability of straps and yokes, contributing to the overall resilience of the built environment. In addition to the aforementioned points, it is crucial to recognize the significance of connection details in the effective utilization of straps and yokes. The manner in which these elements are connected to other structural members directly impacts their ability to transfer loads and provide stability. Bolted connections, for instance, offer a degree of flexibility and ease of assembly, but require careful attention to bolt torque and hole alignment to prevent slippage or loosening over time. Welded connections, on the other hand, provide a more rigid and permanent joint, but demand skilled welders and thorough inspection to ensure weld quality and prevent defects. Pin connections, often used in conjunction with yokes, allow for rotational movement, which can be beneficial in accommodating thermal expansion or seismic activity. The design of connection details must consider the specific loads and stresses that the connection will experience, as well as the material properties of the connecting elements. Finite element analysis can be used to model the behavior of connections under load and identify potential stress concentrations. The use of standardized connection details, such as those provided in the American Institute of Steel Construction (AISC) Steel Construction Manual, can simplify the design process and ensure compliance with industry best practices. Furthermore, the selection of appropriate materials for straps and yokes is crucial for ensuring their long-term performance. Steel, as previously mentioned, is a common choice due to its high strength and ductility. However, different grades of steel offer varying levels of strength, corrosion resistance, and weldability. Engineers must carefully select the appropriate grade of steel for the specific application, considering factors such as the anticipated loads, environmental conditions, and welding requirements. Concrete, while primarily used for compressive loads, can also be used for straps and yokes in certain applications. Reinforced concrete straps, for example, can be used to strengthen concrete beams or columns. Pre-stressed concrete yokes can be used in bridge construction to support heavy loads. The use of fiber-reinforced concrete can further enhance the strength and durability of concrete straps and yokes. Timber, although less common in modern construction, can still be used for straps and yokes in certain applications. Timber straps can be used to reinforce timber beams or columns, while timber yokes can be used in timber frame construction. The selection of appropriate timber species and the application of preservative treatments are crucial for ensuring the long-term performance of timber straps and yokes. In addition to material selection, the fabrication process plays a critical role in the quality and performance of straps and yokes. Steel straps and yokes are typically fabricated using cutting, bending, and welding processes. Precise cutting and bending are essential to ensure that the strap or yoke fits properly and can effectively transfer loads. Welding must be performed by qualified welders using appropriate welding procedures to ensure weld quality and prevent defects. Concrete straps and yokes can be cast in place or precast. Precast concrete elements offer the advantage of controlled quality and faster construction times. However, careful attention must be paid to the design and fabrication of precast concrete connections to ensure that they can effectively transfer loads. Timber straps and yokes are typically fabricated using sawing, planing, and joining processes. Precise sawing and planing are essential to ensure that the strap or yoke fits properly and can effectively transfer loads. Joining can be accomplished using nails, screws, bolts, or adhesives. The selection of appropriate joining methods and the application of preservative treatments are crucial for ensuring the long-term performance of timber straps and yokes. The importance of quality control and inspection throughout the design, fabrication, and installation processes cannot be overstated. Regular inspection should be conducted to verify that materials meet specifications, fabrication processes are performed correctly, and installation is in accordance with the design drawings. Non-destructive testing methods can be used to assess the quality of welds, concrete, and timber without damaging the structure. Any defects or discrepancies should be promptly addressed to prevent potential problems. The integration of digital technologies, such as laser scanning and drones, can enhance the efficiency and accuracy of quality control and inspection processes. Laser scanning can be used to create three-dimensional models of structures, allowing for precise measurements and identification of potential problems. Drones can be used to inspect hard-to-reach areas such as bridges and high-rise buildings. These technologies can help to ensure that straps and yokes are properly designed, fabricated, and installed, contributing to the overall safety and durability of structures.